Now that we've discussed, and I hope we have in our mind, the basic shape for sine of x and cosine of x, now we can talk about variations on those. What's going to happen here is the same thing that happened in your basic algebra course. You learned way back when, you learned the basic shape parabola, right? And then you learned, what if f of x is x squared plus 2? Well, you learned that changing the equation in set and predictable ways changed the picture in set and predictable ways. One way to do this is to be very, very not efficient, just be very pedantic. One way to do this is plot a bunch of points and plot all the points and then play connect the dots. But hopefully the idea is you don't need to do that, because once you recognize that certain changes of equation always correspond to certain changes of picture, this means the basic shape parabola shifted up 2 units. And so you don't need to go through some X, Y column grid graphing business. All you need to do is to move this up 2 units and you're done. Well, the same thing's going to happen here. If we change the equations in set and predictable ways, the pictures change in set and predictable ways. Once you know which change of equation corresponds to which change of picture, then you don't need to do any plotting anymore. You have the graph at the drop of a hat. And so, the same thing's going to happen with sine and cosine as happened with the basic shape parabola. One in particular, we recall f of x equals x squared. I hope most of us know that's the basic shape square function. And I hope most of us also know this. If I take g of x equals negative x squared, you recall what putting a negative in front of the function does? Remember, this alters this picture in a set and predictable way. What is the set and predictable way? Well, what was above the axis becomes below the axis. What was below the axis becomes above the axis. And so this is the same picture, but upside down, if you will. Now, similarly, some of you may have learned the cube function. The cube function, basic shape looks like this. What is g of x equals negative x to the third? What was above the axis becomes below. What was below the axis becomes above. But points on the axis don't change. And so, what was above becomes below. What was below becomes above. But points on the axis don't change. And so that's the graph of the negative x cubed function. So, that's step number 1. If we know f of x is sine of x, and if we know the graph, the basic shape graph is this, then we should know negative sine of x has that same phenomenon. What was above the axis becomes below, what was below the axis becomes above, and points on the axis don't change. And so the basic picture would be something like this. What was above the axis becomes below, what was below the axis becomes above, and points on the axis don't change. So these two pictures need to be in your comfort zone. You need to know, what does the basic sine of x graph look like? Sine of x looks like that picture. What does negative sine of x look like? It looks like that. The positive sine of x, negative sine of x. That needs to be automatic in your mind. Similarly, in an exactly similar fashion, if we have, suppose I take g of x is equal to cosine of x. What does the basic shape graph look like? Cosine starts at the peak. All right? So that's the basic shape cosine graph. What does negative cosine look like? What was above becomes below, what was below becomes above, and points on the axis don't change. And so we get a picture that looks like this. What was above becomes below, what was below becomes above, what was above becomes below, but points on the axis don't change. And so you should have in your mind's eye these four graphs. That's sine, that's negative sine, that's cosine, that's negative cosine. Those need to be automatic, just like there's x squared, there's negative x squared. There's x cubed, there's negative x cubed. Those need to be part of your understanding automatically, without needing to reference the picture, without needing to reference a calculator, without needing to reference a computer. You should be able to be the graph, the cosine curve and the negative cosine curve. Just a rough sketch, doesn't need to be perfectly accurate, but a rough sketch. What was above becomes below, what was below becomes above. Points on the axis don't change. So this is the sine curve, negative sine curve. Cosine curve, negative cosine curve. Those need to be readily in your comfort zone, in your toolkit, ready to use at a moment's notice.